I went into the actual assignment from the chapter 20 part of lesson 4, and one of the selected problems was 20.17. We're being asked to balance the following half reactions and then decide if they're Leo or Gur. Are they oxidation or reduction? So keep in mind, this isn't a complete reaction. It was one of the first things we did was practicing separating the two. This is 1/2 of a complete reaction. So just a note to self, these are already broken in half. So the first few steps we read out loud together a moment ago have already been done. If I see tin carrying a +2, and now I'm pointing at tin with a +4, it's a half reaction. One of the rules says, break it into half. Number 1, okay, done. It's already broken in half. Rule 2 says, balance everything that's not an H or an O. Done. There's 1 tin on each side. Rule number 3 says, balance the oxygens with water. Okay, there are none. Rule number 4 says, add hydrogen ions to balance the H's. Okay, there are none. Finally, we're to a rule that says balance the charge with electrons. So everything was balanced except the charge. When we balance charge, we add electrons. Electrons are negative. They do not have to be the same charge, or they don't have to add up to be 0. They just have to be the same charge on both sides. To balance this half reaction, it was as easy as adding 2 electrons to the right-hand side. Now I have a net +2 on both sides. When I'm asked if this is an oxidation or a reduction half reaction, the loss of electrons shows that it is an oxidation half reaction. That equation was that easy. Adding 2 electrons to the right side brings both down to a +2 charge overall. The loss of 2 electrons created an oxidation half reaction. Let's show a letter B. Same problem, but we have a little bit more involved. Titanium dioxide produces titanium +2. So this is a half reaction. Rule number 1 in balancing, break them into 2 halves. That's already done. This is not a complete. It's already broken in half. So we would add it back to something else. Rule 1, break it in half. All done. Rule 2, balance everything that's not an H or an O. Well, the titaniums are balanced, so that's good. Rule 3, balance oxygens with water. If I have 2 oxygens on the left and no oxygens on the right, I'm going to balance this by adding 2 neutral waters. Balance the oxygens with water. Now I have the same number of O's on the left as the right. Rule number, next one, I think it's 4. Rule 1, break it in half. Rule 2, balance everything not an H or an O. Rule 3, Rule 3 we did with the O's. Rule 4 says balance the hydrogens. Now I have 4 hydrogens on the right. I got to come back to the left. What we do are add protons. Protons are called hydrogen ions. Since I have 4 hydrogens, I better add 4 hydrogen ions to the left. Hydrogen ions carry a +1 charge. 4 H positives plus TiO2 made Ti +2 and 2 waters. Now we consider charge. On the right-hand side, so far, we have a net +2 charge. Ti +2 is making this a +2. Over on this side, 4 hydrogen ions make this side a total of +4. I don't have to make them both become 0, but I have to make them become equal. Take the more positive side and add electrons to it. The more positive side is the left side in this example. To make them both become the same number, I have to add 2 electrons to the left-hand side. The balanced half reaction would show 2 electrons plus 4 protons plus a titanium dioxide forming titanium +2 and 2 waters. When I add electrons to the left, this is a reduction half reaction. Gaining electrons is called Gur. 4 hydrogen ions and 2 electrons brought this from a +4 down to a +2, and now they're the same electrically balanced charge. Let me pause the video and give you some work time. I'll stop, you work, I'll turn the music on. Try letter C. If you haven't written it, take a moment to do so. It's chlorate becoming chloride.